Welcome back, my friends, to the FPV Academy, episode number 2, radio transmitters for beginners. A little late. If you have watched the Facebook stream, you've seen one of the mishaps that's happening when you're streaming live. I hope now it's also live on YouTube, and I hope that we don't have any embarrassing sound issues like last time. So today we want to talk about radio transmitters, and again I have a panel of experts assembled on that topic. Bringing up on the screen right now, we see Monty FPV on the top left. Welcome, Monty.
Thank you.
In the middle we see Travis, not fast enough, Schrock. Hey Travis, how are you?
How's it going? Thanks for having us.
And then on the right, without a video, says Wiffles. We have Scott Aiken, owner and contributor to rotorbuilds.com. Hey, Scott.
Hey, hello.
Yep, can hear you nice and clear. Very good. So today we want to talk about transmitters, and before we dive in and show you a couple of different transmitters, I just want to lay a couple of basics down for those of you who are completely new to the hobby to just define a couple of terms and make it easier for you to follow along. So when you hear the term RC, that can refer to radio control or remote control, which is basically the same. So what I have here in my hand is a single channel binary remote control. It controls my garden gate. There's only one channel and only one command, on or off, I can send. I can press the button, motor turns on. I can press the button again and motor turns off. So if we want to control remote controlled vehicles, we need to give them some fine control, a couple more channels. So the next, where did I put it? The next step up from a binary control system, which only can send on and off, and from the single channel control system would be a surface radio like this one here. It's called a surface radio because it's used to control cars or boats, which in general only need 2 channels to give us full control over their motion on the surface. One of them is steering left and right, and one of them is going forwards and backwards. And because we just don't want to go full speed and full stop, this is also a proportional system, which means it gives us a little finer control over how much throttle, how much brake, or how much steering we want to apply. Now, when we are flying, we need even more control because there's not only the height that we want to control, but also the attitude of the aircraft. So what has boiled down over the last decades of people flying remote control aircrafts is the typical 4-channel remote control. 4-channel because it has 2 joysticks that each have 2 dimensions. And even though there's quite a few more channels that on many, even our simple toy drones you can control, we are referring to this as a 4-channel control because these are the 4 main inputs that we have to control attitude, rotation, and height or throttle with 4 sticks. So if you are a beginner to this hobby, it's a tempting entry to buy what is called an RTF, a ready to fly, which means you get the model and the transmitter in one box, and it's configured to work with each other. You don't have to worry about the setup. You take it out of the box, you charge the batteries, and you go fly. So I have purchased a lot of RTFs over the years, and thus I have assembled a large collection of ready-to-fly transmitters, which None of them I'm using anymore because all of the models have had some sort of an accident or have been repurposed in some way. So none of these transmitters, and I have boxes and boxes of them, are of any use anymore because there's a second very important thing to consider with radio transmitters on top of what I just mentioned before, the human interface. So what are the inputs that I can give into the radio transmitter? The obviously next important aspect of these transmitters is the way they communicate with the model. So each of these transmitters has a radio module in there. Well, this one here actually doesn't. So this is just a human interface so far. In order to communicate with the model, it needs some sort of a radio interface, transmits on a certain frequency, most of them on 2.4 gigahertz, and it's speaking in a certain protocol. And that is different between many models, and that's the reason why all these transmitters in the boxes have no use anymore, because every of these RTF toys usually has a different protocol. So that means I can't use all these transmitters with any new model that I might acquire. So it makes sense, even if you are beginning in this hobby, to acquire a transmitter that you can use across multiple models. If you crash, destroy, lose your model, or if you just decide to pick up a new one down the track, that you're not out of luck in regards to your transmitter and can keep on using this. If you're considering this upfront, it makes sense to invest a little more into the transmitter, because the transmitter makes a big difference in how you can control your model, what you can do with this, and also what models you can upgrade to later on. So we want to introduce today a couple of different options, what you could purchase, and talk about the ups and downs of each of them, so that by the end of today's hour, you have a good overview, a boiled down experience of a few people of being in this hobby for a long time and using a lot of different transmitters. So if you go to any FPV flying event, one of the most popular transmitters is a Frsky Taranis X9D Plus. So there's been a lot of variations of this radio. I don't have one here. I used to own one, but I sold it in favor of a Taranis QX7. But anyway, I think that's a good starting point, just because it's so prevalent in the hobby, and most people you will talk to about FPV will recommend this transmitter. So there's quite a few different Taranis models out there. This is one of the latest and lowest cost Taranis transmitters. This is the Taranis QX7, and this is already a slightly upgraded version, so I've put Hall sensor gimbals in them. You can buy it like that as the, I think, QX7S. So before I go into more detail about this, I want to leave one important comment that Travis did on our pre-framing of this podcast / live stream, and that is, if you're buying a radio transmitter, there's usually a learning curve attached to that, so it makes sense to go to your support group, which is, the group you're flying with or the group you're connecting with online, and see what they have to say, what transmitters they are using. Because even if we're going to make a couple of different suggestions down the track in this episode, you will have the best success with going with whatever transmitters your buddies, your flying mates are going to use, because then you can pick up all the ins and outs of this particular transmitter. Lots of the things we're going to talk about will apply to the various transmitters you get, but how exactly you're going to apply those things, that depends on the exact model you're using. And yeah, that's a lot easier when you have a bunch of friends who are using the exact same model. That's why we're going to start with the Taranis radios, and yeah, just because I think they are currently the most prevalent in the hobby. So Monty, I'm going to use you as the the representative of the Taranis camp in this stream. So yeah, if you want to talk a little bit about why are you using a Taranis and not any other transmitter.
Thanks, Benedict. The Taranis radio, I bought a QX7S due to the price and due to the fact that, like you said, my fellow flyers that I fly with all flew OpenTX Taranis radios. There is a steep learning curve involved with these radios, but if you have people around you, you shouldn't be afraid of it. The radios are complicated, but they're complicated for a reason. They can do an amazing amount of things. They're very, very flexible. But you can do a minimal setup and get your quad flying relatively quickly. And if you have somebody that's there to lean over the shoulder and show you how to do it, it can be pretty quick, and it can speed up the learning curve dramatically. I think they're a great value. You can pick up, I think, a QX7 for about $100 and the QX7S for maybe $130. Parts for it are ready available, but if you get the QX7S, you already get the Hall sensors, and those are they're digital gimbals, and they're more sensitive. They tend to be more precise with your flying, especially with throttle control. I highly recommend if you do look at a Taranis, that you can see if you can get the QX7S to have those Hall sensors, since they're already there. You can always upgrade a QX7, but it's more cost effective to buy them up front, built into the radio.
Yes, that's right. Good summary. So what you currently see on the screen, that is my Taranis QX7 already upgraded with the Hall sensor gimbals. So the difference between the Hall sensor gimbals and the regular gimbals is that the Hall sensors are not using sliding potentiometers, but magnet sensors to sense the position of the stick, which is in the first place more accurate, and it creates less of a friction when you're moving the sticks, but it also lasts longer. So the gimbals in this radio are only maybe half a year to a year old, which is usually not the time where I see them losing quality. Usually after, it's not depending on the time, but it really depends on how often you use them. Regular gimbals will wear out over time and you need to replace them. I hope that's not the case with Hall sensor gimbals, but yeah, I don't really own them for long enough yet to say that. So yeah, as you said, Monty, the X7 series of the Taranis is the lowest cost option. These radios used to be quite expensive. I do have a few different ones on the upper end of the price point. So for example, this is the X12S, which was the first Taranis that came out with Hall sensor gimbals stock, and yeah, has a lot more buttons and switches and knobs and a fancier display, etc. But yeah, basically it's doing the same thing. So I don't fly any better with this radio over the X7. It's just a different form factor. And Then, yeah, one of my favorites here is a massive thing as big as a laptop. This is the Taranis X9E. It's quite an old radio already. I paid a lot of money for this thing. I bought it just after it came out, and it has even more switches or options for switches than the X12, and it's a tray radio, so you're supposed to put your hands onto the radio like this. But again, it's mainly just a form factor. The gimbals are actually in this case exactly the same like on the X7S, and also the firmware that we're going to talk a little bit about in a second is also the same like on the X7, because all these radios are running OpenTX. So we go a little more into detail between the different firmwares, but before we do that, let's talk about the other big camp of radio transmitters, which is the DeviationTX transmitters that I only really got interested heavily over the last half year. Even I know that they existed, and I did have, I think, a Devo 12 a while ago. Got this as a gift from a friend, and then didn't really put my mind into this because it had another learning curve to figure out all these things. So I passed it on to someone who did not have any money but a lot of time to figure things out, and he's now happily flying with that. So Travis, not fast enough. I'll take you in this episode as the representative of the deviation radios in general. So I know that you are using a deviation radio for a long time, and I think that's your only radio that you're currently using. So yeah, tell us a little bit why you're using a deviation radio and why you think it's good.
Well, I guess I'll start with why I got into deviation. I believe the deviation project started back in about 2012, and it was an open source project that's kind of parallel to the OpenTX project. And OpenTX and deviation were really the only two at the time. They're still the two major players today. And OpenTX at the time they were focusing on hardware. Gosh, I don't remember, some kind of Turnigy radio from Hobby King that was on the affordable side. And I had flown fixed wing airplanes for a long time, and I wasn't looking for a cheap radio. Deviation focused on more of a higher end Walkera radio at the time, and although the brand name wasn't well known, the radio itself had the feel of a top quality radio. It had ball bearing gimbals and good weight to it, nice balance, color touchscreen menus. And that's what attracted me to that project, was some of these advanced features. Color touchscreen in 2012 on your transmitter was a little bit ahead of its time. So, but beyond the features, because we all get attracted to things by the frills and features that they have, but what is the experience actually like using the radio? And I paid attention to the project for a while, and I saw the firmware developers for DeviationTX very involved with their community. And I joined up with that community before purchasing a radio and reached out to these guys. And they were right there on the ball to talk to me, to encourage me, let me know they'd be there to answer my questions. So as Monty mentioned before, that was my version of reaching out to a support network. Because at the time, it was something where we had to buy, I think my radio was close to $300. We had to buy a radio and then immediately go and erase it and hack it. It didn't come out of the box with that firmware. So I was looking for some pretty advanced support. So again, it just kind of goes back to that support thing. Where is your support network? Who are the guys that are going to be available to help you, and what are your intentions? Fast forward to today, there are now multi-protocol modules that come pre-installed into deviation-based radios, and we can just jump on any of the big box stores and order up a radio, and it comes pre-flashed, and it's got every module in there, and it can control all the different radios. all the different models. One of the advantages, I think, for a beginner to the DeviationTX firmware is the fact that it has what's called a USB file system. You can plug that radio right into your computer and download or upload a model file straight into it. There's no additional software that's required on your computer to do that. And if you know other people flying a Jumper or another deviation-based radio, this is a huge advantage for you in learning, because you can upload model files that have all the mixers populated, the inputs and outputs populated, and learn from examples as opposed to trying to learn step by step in chat rooms or guides or tutorials, trying to set all this up yourself. So I think that that about sums it up for deviation as far as what's important for a newcomer. Actually, I'd like to add one more thing. I know we're talking about the quality of gimbals and Hall sensors, and guys, if you're new out there, don't get too caught up in this stuff. Radios have gotten so affordable these days that for the amount of money that you're going to spend eating out with your family, you can buy a transmitter, and you don't have to start with the best of the best. I have flown on non-Hall sensor gimbals since before 2012, and they're still, at least 98% accurate. They have wear, potentiometers do wear, but I've got some Hall sensor gimbals, and they're sitting in my park box, and I haven't gotten around to installing them yet because it's just not that big of a priority for me. It's not affecting my flying. So you don't get too caught up in too many of the features and frills. Just get yourself a good radio, and get yourself a good support group to set that radio up, and you'll be fine.
Yeah, thanks a lot, Travis. Before I go on, just a little bit of a hint on my to my three participants in the video session. I'm not sure if this is my computer or yours, but I hear this Discord blink, blink, blink all the time. So if you guys don't mind having a look while I'm not talking, to turn off the sound notifications to from your, I believe it's the Discord chat, so we don't have so much of the blink, blink going on in the recording of the stream. So just touching on what both Monty and Travis said, I just want to quickly talk about what does it mean to set up a radio. Why do we need to do some extra configuration when we have some sort of a radio and some sort of a model that we have both purchased or built separately? And the main thing when we're talking about setting up a radio is just making sure that the right inputs that we're giving arriving at the right channel that our model is expecting. So because these two devices have not been produced by the same company, by the same guy, they don't necessarily know which channel belongs to which function. So, for example, a big part of setting up is making sure that my yaw channel, for example, that should rotate the quad like that, is actually doing that, and that my pitch channel is moving it back and forth and not left and right, and so on. So that refers to the four main inputs to my sticks, but that might also refer to extra functionality like arming it or changing flight modes or lots of other things. So this is what we've been talking about, what we refer to when we're saying setting up a model or setting up the transmitter in general to work with your model. And that's also one of the main things that differ from radio to radio. So every proprietary radio, like for example, this Spectrum radio here, will have a different way of doing this, like my Taranis radio, and which will have a different way of doing this, like the, for example, this deviation radio here. So the The nice thing about the Taranis radios and the Deviation radios is that the firmware used on these radios, the operating system, is used across a variety of different transmitters. So when you have when you have someone showing you in person or in a YouTube video how to do that, then you can apply some of those principles to your radio, even though that person might have described this on a different radio. So next, let's talk about this radio here, which is a DeviationTX radio, the firmware that Travis has just been talking about. But as opposed to the way you did things, Travis, this thing comes already pre-installed with DeviationTX. So if you turn it on, oh, that was too quick, then it'll have a little flash screen telling you what version of deviation that is. I'm going to see if my video camera actually picks this up. So it says about deviation here, and then you can see the firmware version, and they also give you a link where you can go to and read more about the project and download, if you want to do that, the latest nightly build that what the developers just have come up with yesterday, and download that version of the firmware and put it on your transmitter to get the latest features or the latest support for different protocols, etc. It's usually not required. So as opposed to back in the days where we used to buy radios and then immediately had to hack them and with the warranty in order to get the functionality that we want. Now, manufacturers have caught up on that, and they're using a software that they haven't developed themselves, but which is supported by a community, and modify that software, sometimes with the help of the community, to suit their radio models. And yeah, I think this way we get the best of both worlds, a radio that is completely set up by the manufacturer, but has all the features that that the community has come up over time and put it in software here. So this radio here is a Jumper T8SG V2. It doesn't say V2 here, but you can see this on the shape. The original T8SG looks very different, a little bit like a Futaba radio. I think that is the reason they went away with that from that design, because I think Futaba had an issue with that. So this is the T8SG V2 Plus. Plus in this case refers to the, I like it a lot, very nice OLED screen and already stock installed Hall sensor gimbals. So to talk a little bit about more about this radio, I've invited Scott Aiken, aka Wiffles, to today's chat, because when I was doing a little bit more research to see what other people are having to say about this radio, I came across a very nice detailed teardown article on rotorbuilds.com, and I thought, hey, this guy probably knows even more about this radio than I do, even though I have a whole bunch of them and I've taken them apart and flashed them and done all sorts of stuff to this. By the way, there will be a video coming out that I've just finished editing before doing this stream about sharing the model files for this radio. But yeah, before I talk more about this, I want to hand over the mic to Scott and talk a little bit about his experience about this particular radio. And yeah, I'd like you to tell us your experience with this radio and why you think people should use this over any other radio. Handing over to you, Scott.
All right. Well, yeah, just to give a little background, I've only been using this radio for, the past several months. So I started out with Spectrum, and I've been using Taranis for about a year before that. But then Jumper came up with a T8SG, was their original model, and it was it looked like a Futaba clone. It was black and silver, and it was, what caught my attention though is that it was really small, and it did the multi-protocol. So I thought that was kind of neat. So it's not the best gimbals, that original model, and because the design wasn't really it wasn't their own, but the size is what really caught my attention. Deviation was just was there, and it ran it, and I thought, okay, I'll get used to this. And I find it real reminiscent of the Spectrum interface. It uses the same kind of menu system, and it with the crosspad buttons, it's definitely a lot more intuitive than OpenTX. So it's at least from a beginner perspective, the interface is a little nicer. But what's really nice about these radios is the size. They're small. As soon as I got this, I stopped using the QX7 because that radio is a bit chunky. It takes a bit to pack it up, and to me, I prefer a small radio. I like to pack things up light. So I started using that original Jumper. Then I had done some little communication with the company there, and they told me they're working on a few different radios. So I was waiting for the Plus, which they said has an OLED and Hall sensors. And that took several months, but when it finally came out, it seemed to be a pretty good product. The gimbals, they have less throw. What most people would say is you go for the Taranis because you have a lot more throw on the sticks. The sticks are bigger and they have more range. But I've gotten used to this, and I really like it. You don't have to move the stick as much to get the same kind of reaction. So if you're used to like a Taranis or one of the larger radios, you probably want lower rates because it's more sensitive. And I also have the X-Lite, the Frsky Taranis X-Lite. That even has smaller gimbals than the Jumper. And I find that with those gimbals, I even need to adjust my throw a bit more. So it's kind of a good middle ground between the large gimbals and the really small gimbals of the X-Lite. And I use the X-Lite off and on. I like that radio. It's good because it's small as well. But I keep coming back to the T8SG Plus because it's just a nice little radio to hold. It's great for pinching. I like the size, and it's lightweight. The plastic it's not the best, but it's pretty decent for what it is. And if you try to compare those two, you're probably going by price and the name. Frsky is the top name right now in FPV. But if you want that multi-protocol support, you're going to have to get a module for the Taranis, which the X-Lite does support modules, and they do have slim modules for that to do the multi-protocol. But if you're looking at pure cost and you want multi-protocol, then the Jumper is going to be a little cheaper option. But one thing, when the Jumper was first announced, there was they said it supports modules, and big question there was, does it support Crossfire? And there's at the time there was no Crossfire support in Deviation. It was only through PPM, which is just a catch-all kind of protocol, and it's got a little bit of latency, so it's not ideal, and it's not what you'd want. You want to have a serial connection directly from the processor of the radio to the module itself. So I've been following a thread on Deviation forum for the past several months, and there's one particular developer who's been working really hard to add this support. He added both an S-Bus support, which I'm not too clear about. Could be worked into R9 support. I'm not sure, but he also did a Crossfire protocol. And while it doesn't support Lewis scripts, it does work. And I managed to configure the module on a Taranis. I could do all that. But word on the street is TBS is coming up with desktop software to configure the Crossfire module. So the lack of Lewis scripts now for Deviation may not even be a problem when that comes about. And if you do OSD PID tuning and all that, then you don't even need Lewis scripts for that. So I personally don't really find much utility in the Lua script support of OpenTX. So that's one of the things that the cons to running Deviation is there's no Lua support, but maybe it's not even necessary in the near future. But particularly concerning the jumper, to do Crossfire, to run the Crossfire micro TX module, you do need to modify the pins. They, I don't know what Jumper did. They didn't hook up the last pin, so you need to redirect the, it's a real simple mod, but to make that work, you have to mod the radio. There's another mod that you can do. It doesn't come with a speaker, so it doesn't talk to you, but you can add a sound processor chip, and they even have a spot for it. It's like Jumper planned to put this in there, but they didn't do it, maybe for cost saving or not. But you can see there's some speaker grills on the front, and there's even a cutout inside for the speaker to be mounted. Plus, there's pinholes on the main board, so you can put a speaker in there. And Deviation does have full audio support. There's even I think a sound pack generator or something that you can use to make a sound pack for it.
Yeah, I was thinking about making a sound pack, but then I realized, oh, this thing doesn't even speak. Needs a couple more mods. Yeah, so everyone who's watching this, Scott did a really nice tutorial to do all these things, to bridge the necessary pin to do the Crossfire support, and also to put the audio module in there. But as you said, this is probably not what most people want. If you want to fly a Crossfire, you're probably gonna buy Taranis for the extra support with the Lua scripts, etc. Where this radio shines, to sum up what you said, is at first the multi-protocol support. So I don't even have a module in there. So this here is an empty module bay, doesn't have your module in there. I'm only operating this with the built-in 4-in-1 radio module. So 4-in-1 means that it has 4 different hardware components to cover different ranges of protocols. And if you look into the menu, it's pretty overwhelming in terms of how many protocols it supports. So I think it's like 40 or 50 main protocols with a lot of sub protocols, which basically means that this transmitter is supporting almost every model that I have here. So yeah, first and foremost, all the Frsky models, so everything that we fly with our Taranis radios is supported, and the DSM models, so all the Horizon Hobby, Blade, Spectrum, bind and fly models, you can all fly them with this radio, and then also a lot of the toy models where you usually don't have any other choice but the RTF transmitter it came with. You can also fly them with this radio. And yeah, the other main thing that you mentioned, Scott, is that it is quite a bit simpler to use than OpenTX. Even if I've been using OpenTX radios for quite some time, I still find myself every time pressing the wrong button to get into the wrong side of the menu. It's just not that intuitive. A lot of that doesn't make sense. It's made by engineers. It's not really made by people who had a discussion about how do we make the best user interface. It's kind of weird. You just have to long press something or press to the side to get to some menu. The DeviationTX menu is a lot simpler, made for people to actually use it without reading the manual. It just has like a simple kind of branch-based interface, and you get to the points you want to use a little easier. But having said this, if you're really digging down to this and configuring the mixer, you might want to argue which one is easier to use. I struggled quite a bit of setting up the mixer files on the Jumper after being conditioned to how the mixer works on OpenTX. If you're new to this, mixer means exactly what I mentioned before. Mixer means creating the association between what am I doing with my inputs, with my sticks and switches, and what is coming out at the radio side, what is actually transmitted to the radio. And which brings me to the main advantage from my perspective that Travis mentioned earlier, and that is this radio, and I think most or all deviation radios, you can connect them over USB to a computer, and it creates a USB storage device, which means you get on your computer a storage device where you can have direct access to the files that are on this radio. Most importantly, the model files. So if I create a model that on the radio that works with, for example, this here, a Beta 75X, and you want to copy my settings, the only thing I have to do is connect my radio to the computer, copy the model x.ini, and send it to you over email or any file share service. You can just download this file, pop it on your radio, and with very, very little effort, you get all the setup that I have done. If, for example, what channel belongs to what input channel belongs to what output channel, what are the sticks doing, the switches doing, and how is the screen layout configured. So yeah, I think we covered most of the topics that you gotta know as a beginner, and we've boiled it down to, if you don't want to break the bank, and if you want to have something that works well for you across many models that you can buy these days, and which has a large community of support, it comes down to these two radios and its variants, either a Taranis running OpenTX and having the option of installing radio modules in the back, or a deviation radio, in this case represented by Jumper, because they are already pre-installing those that firmware onto the radio, with also the option of installing modules, but not even necessary in most cases because it supports so many protocols out of the box. So to close it off, let's have a look into what we usually do a lot earlier, and let's pick out some questions from the Discord chat or from the YouTube chat to see what's going on, and yeah, get us back down to basics in case we're flying too high again, and see if we can pick out some questions from people who are new to this hobby. I realize that most of you who are watching are probably in the hobby for quite some time. So for future episodes, if you like our content, please share the links to our YouTube streams with your friends so we get some fresh blood in here and some fresh questions. Remember, no question is too stupid. The only stupid questions are those that you do not ask. So yeah, guys, while I've been talking, did you have a look at the chat? Did you pick up any questions that you want to touch on?
I have one thing I wanted to add concerning the jumper and deviation. If you want to run a sim on a Mac, like an Apple computer, you're going to have trouble because Mac has a hard time supporting USB HID. But what I do is I got one of those little DSMX USB dongles for playing wirelessly. So that's one little thing. OpenTX or the Taranis radios work just fine on the Mac. So, you know, just one little caveat.
That's a good point, even though I think there's a solution to that. We're currently working on a project where we want to enable schools to build their own drone, and in order to get some training before they crash them, we want to have them practicing on simulators, and ideally you want to have them doing that with the same transmitter. And I just got some info yesterday that I haven't processed yet, where someone is sending me a tutorial how to get these radios to work on a Mac, because that's all what I'm using in this household. I have abandoned all Billy boxes here. I used to work professionally with Windows, but I have stopped doing that. Yay! So yeah, Jens,
Awesome.
Monty, Travis, did you pick up any questions from the from the chats that you want to touch on?
I saw something come up here on Discord. Our buddy JT Walker, he's got both a Devo 7E and a Jumper radio, and he's got an issue where he's in the S-Bus protocol, and he's not getting his auxiliary channels to show up. So I thought I would briefly touch on just some of the first things that we kind of looked at as we chatted back and forth, and really the only direction that I can think of to go from there. So when you guys are having an issue setting up your radios, there is a page in your radio called the output monitor. And the output monitor is absolutely key to confirming whether or not you've done your job to set your radio up correctly. It is going to give you a visual representation of what the outgoing signal is that's being sent. So he was not seeing his auxiliary channel switch on his jumper. So the first thing we went to is, do you see them moving on the output monitor? And he said he is seeing them move on the output monitor, but they don't seem to be coming through on the receiver end. So to touch briefly on, we talk about how these radios come pre-flashed, and we're not always in a situation where we can avoid flashing firmware. Sometimes flashing updated firmware is a fix for some oddball problems. So if you've got a problem that you just absolutely can't solve, the advice that I would give you is start with a new model, begin setting up a new model, and just go through the steps all over again. If you do that and that doesn't work for you, and you still have something strange like this where there's a good picture of it, the mixer output is showing that you're sending the controls out, but you're not seeing them populate in Betaflight or in the craft that you're working with. It may be time to go ahead and say, maybe I've got a glitch in my firmware, maybe something's not working right, and flash new firmware. S-Bus receivers from Frsky do have multiple different firmware versions that you can download and flash onto the receivers. I've seen that fix a few glitches and problems. The jumper might need to be flashed in JT's case. So it's a last resort, but if you've got some strange behavior that you can't explain and you've tried everything, received support from the community, flash the firmware on them, give them a new life, and see if that doesn't bring it around.
Yep, very good, Travis. Thank you. So you also to add to that, one of the reasons why I really like Betaflight flight controllers is beyond the capabilities that you can, change all those settings and flash new firmware onto them, etc. The main reasons why I like them is you can connect them over the USB port to your computer, and then you can see what it receives from your radio transmitter, and this way make sure that all the setup from the very end, from the very beginning, I'm moving the stick to the very end, what does the flight controller actually receive in terms of input, that is correct, and that you can make sure that it's 100% on spot, that the gimbal's sent up properly, that the endpoints are properly configured, etc. When you have closed flight controllers, like for example the ever popular Blade Spectrum Inductrix flight controller, you cannot connect it to a computer to check those inputs. So you're basically flying blind. You're setting it up until it sort of works, and then you just go from there. Whilst if you have a controller where you can connect it to the computer and then get that feedback loop to make sure that you're setting it up correct, your chances of getting it right the first time are a lot higher.
Hey,
So,
Benedict, we had another question in the chat, and this was first person Q. He had an issue with his transmitter where your input stopped responding, and we were talking with him in chat. That's something that can happen to your transmitter if one of your gimbals stops working or switch stops working in your transmitter. The first thing I'd recommend is to open up the transmitter and inspect the cables to make sure you don't have any broken cables or a loose connector. On a Taranis, they have connectors to the boards. Those can wiggle free. But if the plug is in correctly, and you reseat it and you still have a problem, you may need to replace that switch or gimbal.
Yes, very good point. So this is, one of the big advantages of the Taranis radios, that you can replace all those parts. So when I purchased my Turnigy 9XR radios, I stocked up on spare parts for them. So for example, here this is a replacement gimbal, just has a plug on there, plugs onto the control board. Actually has two plugs for each axis. So one for the vertical and one for the horizontal axis. Two potentiometers in here. And when one of them breaks, you can just replace that instead of buying a whole new transmitter. And yeah, some of them you might drop it or just wiggle it around, and some of these cables, these plugs might come out of the socket. Or what also happened on some of the radios that I used a lot, if you are looking how the mechanics work, so one of the potentiometers on the side is fixed in place, and the other one needs to move around because of the construction of the gimbal, which means that this cable is constantly on every move back and forth, is moved back and forth. So eventually it'll break, and you might just need to go in there and replace the cable here. Needs a couple of solder joints here, or maybe just cut it and solder a new piece of wire to this, which also, if you are into that, leaves a lot of room for customization. So for example, what I've done on my X9E is, one of the things that we don't need on these radios when we're flying multi-rotors is the trim switches. So yeah, quick tip here for the beginner: don't use them, just leave them alone. So if you are out of trim, yeah, bad things happen. And I got so upset about these trim switches of me accidentally bumping them and being not in the center position, and then things just fly sideways or it doesn't arm or whatever. I opened up this thing and I have removed all the cables going to the board from the trim switches. And while I've been doing that, I thought, oh, yeah, maybe I can use them for something else. So I have soldered up a whole bunch of wires, and all these trim switches now go to other inputs on the radio, so I can use them as momentary switches. So for example, I put the trim to the left, it tells me the voltage of the module. I put it to the right, it tells me the voltage of the radio. I move it up and it tells me the timers, and yeah, lots of other things you can do. But yeah, don't want to go into too much detail of that. But yeah, if you don't see your model doing what you're expecting at the input, one of the problems you might experience is that just the physical connection between the stick and the mainboard in there is broken in some way. And that's why a great tip, Travis, you want to follow the signal chain from the sticks down to the module. And the first thing you want to look at is the input mixer on the radio, telling you how the sticks are moving. Maybe you need to calibrate your sticks to make it work properly. The next one is you want to look at the output, what's actually being transmitted, and potentially configure the mixer. And then, if you can, look at the module, what it's actually receiving. So yeah, I think all these things make a lot of sense for the engineer. Don't make too much sense yet if you're a beginner, but if you're entering this hobby with the intention of learning something, not only to fly toys around, but maybe for some sort of an engineering career, it makes total sense to understand signal chains and following them down the track until you get the signal that you're inputting out at the other end. So while I've been talking, guys, did you find anything else we need to talk about? I see there's a lot of stuff going on in the various chats. I don't have the bandwidth to read everything right now while I'm talking, but maybe you've picked up something. And if we missed something, or if you're just watching the recording of this episode or listening to it, because I also plan to upload this as a audio-only podcast, then you might just go down into the comment section of the video or podcast and leave your questions in there. And next time we come around and talk about this topic, we pick up your questions on the way. So, gents, anything else
I've
that
seen
you
a few
picked up?
questions come up on binding the jumper radio to Frsky. So a lot of the bind and flies out there are most commonly Frsky, and then if you end up with a jumper, you're crossing protocols. You're using the deviation with the Frsky protocol. There is, when you're setting up your model and you're getting ready to bind, you select the Frsky X protocol, and then you go one step further to drill into that menu, and you click on that, and you'll find some more options. One of them is what's called frequency find adjust. So the Frsky radio to a native Frsky receiver automatically links up with exactly the right tuning of the frequency that it connects on. On a jumper, the instructions that you're supposed to follow is to drill down into that frequency find adjustment and toggle it, initiate your bind and toggle it up and toggle it down until you see the bind lock in solid in the middle. So there'll be a range as you adjust that frequency where it is bound, and as you deviate from that range to one side or the other, you're going to lose your bind, and you want to pick the middle point on that bind. So I've had to, adjust 35, 40 steps to lock in a good bind on certain receivers. And I think that's really an advantage that we've got the added control to make sure that we lock in and get the exact right frequency. But that may be something that you skipped in your setup. So I definitely do that and find that range, pick the middle point, and you'll maximize your solid lock.
Yeah, very good. Thanks, Trev. I just put this up on the screen while I've been talking. I don't exactly understand what this is doing because but we don't need to go into detail about that. So this is probably a lot more complicated than we can.
Just think of it like turning a radio, an old-fashioned analog radio dial, where you're tuning in your radio station and you just want the best sound.
So this is one of these settings where you either just have to muck around with until you find a setting that works, or you find someone who's telling you, I've tried it all, and now I'm giving you the magic number that you need to put in order to make it work with a certain receiver. I had a similar thing where I do have a receiver that works okay, but it takes 30 seconds or so to bind every time you turn it on. And someone told me, I haven't done it yet, if you change around with that fine frequency adjustment that you can mitigate that problem. Yeah, very good.
I can add a little bit to that.
Oh, yes, please.
One trick is to go in intervals of 10. So start at 0, maybe go to -10, go to -20 until you can get a lock. I found like XM Plus, maybe -10. Sometimes I get -20. XSR maybe around -40. It depends. Some receivers will take it at different, but try in intervals of 10, -10, -20, -30, -40, or you can even try 10, 20, 30. And once you've got it locked in and you've got it bound, then you go into your OSD and set up your RSSI, or even on your computer, look at the RSSI and fine tune it from there. So you can fine tune to get your RSSI as good as you can. So once you've got the bind, then you can fine tune.
Yeah, excellent. Good tip on that. Yeah, I think RSSI and telemetry and how to increase range, etc., we can touch on that in one of the next episodes where we're going to come back to this topic. So for those of you who are new to this channel or new to the FPV Academy, what we plan to do here is have sort of a revolving set of topics, because all these things are repeating themselves over and over again. They change over time. So we've been using radio transmitters for decades now, but they constantly change, and in the current quickly moving industry. We have new stuff coming out every week. So we will come back to this exact topic in maybe 4 or 6 weeks and talk about it again with new stuff that has come out in the meantime, with new questions that have come up in the meantime, or just with deeper topics like, for example, telemetry, RSSI, fine-tuning, setting up models, etc., etc. So we have almost, I think, reached the 60 minutes. I think we even went across a little bit already, even not considering my little stuff up in the beginning of not starting the stream on time. So any last thing, any last comment you guys want to talk about, or any closing words you want to have to sum it up?
I'd just like to thank everybody for joining us again. You know, if you've got people that are reaching out to you for help and you're just here to watch, you know, bring some questions. Let newcomers know that we're here and that we're back every Sunday and enthusiastic to help out and get people pointed in the right direction. So, thanks for joining us.
Excellent. Monty, you have any closing words to say? Anything you want to add to it?
Yeah, it's the radios are a tough topic to cover in 1 hour. If you guys have questions, please reach out to us. We're happy to help. They're complex, and if you don't have somebody to work over your shoulder or to lean on, it can be frustrating. So we're here to help, like Trav said.
Awesome. Thank you. Thanks for joining us today, Monty. And yeah, Scott, thanks a lot for joining us today for the first time. If you want to, you've been a great guest here. Happy to have you on more of the episodes. Thanks a lot for sharing your experience with Jumper radios. Is there anything you want to say to close it off?
Yeah, sure. Thank you for having me. And just one thing to add: if you don't know what radio to get, find a local racing chapter on your Facebook or something. Go to a race. You know, feel some of the radios. You know, it's very personal. You know, it's what do you like to hold? You know, it's not all about what firmware you're running, what protocol you're running. It's really about what radio do you like to hold, what radio do you like to carry.
Exactly, good point. So there's quite a few people who don't like one or the other radio because it just doesn't feel right in their hands. That's one of the reasons why I got rid of my X9D, because it just felt odd in my hands, and I'm a lot happier with a lot of different radios. So yeah, good point. Thanks a lot for joining us. If you want to see more of the stuff that Wiffles, aka Scott, has put up, go to rotorbuilds.com, where he spreads a lot of his vast knowledge. So that's it for today's episode. The next one, well, we haven't talked about this yet, but there's 2 main topics left from our 4 revolving topics. So we still got to be talking about battery charging or battery flight batteries in general, and video transmission and reception. So I would say, deciding it on the spot here, episode number 3 is going to be about video transmission and reception. So if you want to tune in on the next episode in exactly 1 week minus 1 hour from now, we're going to be talking about FPV video transmission on primarily 5.8 gigahertz. So thanks everyone for joining, and we see you on the next one.